Hi, my name is Chase Renanzi. I was the Group 4 reporter to the gas turbine experiment. As you all know, we didn't really get to do the experiment just because it wasn't here. I don't know if it's still here or not. But bear with me, because this is probably my first time going through this. So, quick overview. We're going to do look at the objective, the jet, analyze the actual project and what it was. Then we're going to look at what we were asked to find, go through some equations and stuff, then some results, and then that'll follow with some errors and stuff that were possibly the other groups had because we didn't get to do it. So, all right, the objective. Sorry. Was to understand how the actual turbine works. We've all kind of learned how certain turbines work. We're all mechanical engineers, but we were asked to record values. I analyzed some values in between the ranges of 40,000 RPM and 80,000 RPM. We're going to look at temperature, pressure, and thrust. As well, we're going to show some calculations that we use to quantify the experiment. So, let's move on.
No.
It's not working. What's that? Okay. Keep it going. Here we have two diagrams. One that's obviously in the lab manual, and then there's a corresponding TS diagram. As you can see, from 1 to 2, it goes through the compressor. Both pressure and temperature increases in this stage. Then from 2 to 3, goes through the combustor. The air goes through the combustor. Temperature increases while pressure remains the same. And then from 3 to 4, the air goes to the turbine, and that's when temperature decreases slightly. And then 4 to 5, finally, it goes to the nozzle stage where pressure drops, and temperature, it's supposed to decrease according to this TS diagram. But according to the factory results, that did not happen. So, but it should decrease. Now, what we're going to look for, we're asked to find mass flow rate of the air, the thrust, as well as the fractions of fuel, the compressor work, and the turbine work. Here's some equations that correspond to those. The mass flow rate we can be derived from that equation right there. Thrust as well is given these two equations, as well as fraction. And both work with the turbine and the compressor. Now some results. Here we have I have a graph of the table of results. As you can see, we were asked to calculate at 40,000, 50,000, 60,000, or 70,000, and 80,000. And we also wanted to do some in between. But the overall mass flow rate average, we got to be 0.3138. The standard deviation of that was 0.051. And then the thrust, on the other hand, kind of forces, the average was 7.725. And the standard deviation of that was 1.022. Some more results. The fuel fraction of the combustor. We analyzed over a certain range of RPMs, and we got an average of 1.05, and the standard deviation was 0.054. Now, I do want to note on the previous section, I used the first set of old data from the Google Docs and analyzed that, so I kind of maintain the consistency. But moving on, fuel fraction of the nozzle was negative, the average. While the standard deviation was 0.04. And then the work of the turbine and the work of the compressor should match each other. One should be positive, one should be negative. It's kind of, work in equals work out. So, and that's what we got here at 30,000 each for the average. Now we're going to analyze this a little bit. Like I said before, the temperature at 4 is supposed to be greater than the temperature at 5 according to this TS diagram. And that also corresponds with the most of the data given in the Google Docs. Now the factory results actually show that the TS diagram, that temperature 4 was actually less than temperature 5. Not by far off, but it was still a little confusing to me because the old data showed the corresponding with the TS diagram, while the factory data did not. Possible errors that might have occurred, the interpolation of the volumetric flow rate to determine mass flow rate and thrust. Both of those could have been affected if my interpolation values were off. And we also assumed static air. Here's some references. Just one website really is my picture. So, but I'll open it up for any questions.